Okay, we are recording. So first of all, I want to give you some tips about doing a report. So it's very important when you present a report that you give a report of high quality, no? So I'm sure you are using Microsoft Word. When I use Microsoft Word, I always activate this option that show me every time that I make an enter, it show me the enter. So you know where you have enter and you know where you don't have enter. And if you put a space, let me show you, for example, here I'm going to write USA, space, USA. I know there are two spaces between USA and USA. If you don't have this option, you don't know. So definitely it's better to work with that. So by default, when you open a document in Word, as you can see, there is between one paragraph and the next paragraph, there is spaces, and you want to avoid that. So you can control that at the level of the paragraph. No, we have an option here, paragraph, and look at. This is the space in point that you want before a paragraph. This is the one that you want after a paragraph. So I always put that in 0. And this is the space between line. So I just put it single line. So as you can see now, my paragraph don't have any space before and any space after. So let's say that I have to do my report. Let's bring some text from a web page. Okay, let's say that I need this text. I'm not going to type it, just copy it. So we have two paragraphs here. Okay, here is the two texts, and you want to show your code. So of course, I see code that say, for example, if there is a condition, let's say A equal to B, then what you want to execute if the condition is true is way behind. It's not just there because you unfortunately don't change the paragraph. So you have a paragraph which say after you want, for example, 12 points. Let's put. So if you put your if and then you say statement 1, statement 2, look at the space that you have between them. Ugly, difficult to read. So of course you cannot give me something like that, no? Okay, let's put the paragraph again in 0 here. And when you put code, there is something that is very important. Present your code well. So what I do, for example, I'm going to insert a table here. So I go to insert a table, and it will be just one cell, one by one. And I put things inside. So let me bring some code that we have been doing from the virtual machine. Where is the virtual machine running here? It is here. Oh, we have this exercise. Now I remember. Okay, so for example, we have this info for this. No, it's not a code. Okay, we have a des file. Okay, let's say I want this code. So I'm going to copy it. Let's say I want just this part. Copy it. I go to Microsoft Word. I'm going to paste it here. So when you paste it, you have several options. I always paste special and formatted text. I don't want it to bring any things from the other place. It's why I do that, no? So what is going on there? I didn't save it, so maybe we are Word not responding. Let's close that. So I'm start. Oh, okay. Thanks to God, he did have a temporary copy. Let me do paste special again to see if it worked this time. What is that? Doesn't like the paste special that I did. Copy. Let me open Notepad to see. Well, this computer is not the best one because the resolution is very low when I put the video bin, make it difficult. Okay, let me go to Notepad to paste that. Oh, same phenomenon. This might be something of VirtualBox that doesn't work. Edit copy. Program. Wow. Okay, I'm going to bring text from the internet better, because otherwise I will not be able to show you what I want to show you. Source code. Let's find some source code online that I can paste. Oh my God. The computer has something today, yeah? So let me try to do a demonstration. I will type it by myself. So normally what I do, as I was telling you, I activate that. I look at, I cancel this. I don't want this for nothing. Okay, let's say that here you want some piece of code. What I do, I insert one cell, a table with one cell, and I put my piece of code. Let's say that we are going to do a program that show hello world in C. So I include the stdio.h file. Then I have my main function. Okay, look, this I cannot be a capital. Okay, so what changed that for you? You have to change it again. Of course, indent what is inside the body of the main function. So for example, let's put print f hello world \n. Okay, this will be my code. So I format it so that the cell have some color inside. So for that you can go to table property here. table, borders on shade. And where is the shading here? I put a light gray. And my text is a little better. Now, the font by default is not a good font because look, if you write, for example, hello, and you write hello, the lowercase hello is smaller than the uppercase hello, as you can see. So what I do, I always use a proportional font like this one. Look at the hello now. Doesn't matter. The capital O and the lowercase o have the same length, and it's better to use a proportional font here. You can use Courier New, or there is another that is called Console. Let me go for it. Consolas. So if you prefer it, but it's much better. Okay, those curly things that does not exist in the language, you need straight quote. So when you present something, be aware of that, no? That in the programming language, we don't have this curly quote. So let me copy from some place, if it let me, straight double quote. And replace them. Straight and curly quote. Let's see if we find them here. Okay, what I want is this one. So I'm going to copy this one. And I'm going to put it here. So past spatial, and formatted text. Okay, we have the straight one. We have the straight one. So what is the objective? That you can, if you want to put that a little like that, you can do it. Okay, you can at the level of the code close it if it's necessary. You will generate your, let me save that. Let me generate it, for example, in the desktop. So desktop here. Okay, let's call it test. Okay, I'm going to generate a PDF. So save as on the desktop, PDF file, save. Okay, generate it for me. Maybe I could have put some line at the beginning. We can put it very small so it's look a little better. Like we have some space at the beginning. Okay, this is my code. So let's generate again the PDF file. On the desktop, I want to generate a PDF file. I'm going to overwrite it. It's open, so I have to close it first. Again, on the desktop, PDF file, save, and overwrite it. Okay, I have it here. Look at the presentation of that, no? It's nice. The good thing that if I want this text, I can copy it. And for example, you give me a source code and I want to verify it. I don't want to type it. I want you to make it easy for me. So I can copy it and I go to my virtual machine and I can just paste this text. So for example, let's create a hello.c. I want to see if it's work. Edit paste. But it's not working between, let me see that. Setting, advanced. Yeah, it is bidirectional, so why it doesn't want to work? For C, Doesn't pass it from the host computer to the virtual machine. Let's boot it to see if it will boot it. When it's come back, this feature work or it doesn't work, we will see. I think I did install it when we installed this virtual machine, no? Yeah, that was made by us at the beginning of the class. So let me see. I copy that. Can I paste it there? Virtual machine, paste. Ah, finally. Okay. So I do my let me go in the desktop, create a hello.c file. I receive the PDF. So of course I take this. I receive the PDF from you. I copy it. I go to the virtual machine. I'm already in insert mode and I paste it. By the way, here it will be better with a return 0. Okay, so let me compile it. gcc-o, I'm going to call it hello. Compilation was done. Let's run hello. Okay, it's work. I give you a point and that's fine. But you make my life easy. Now, if you do something like that I don't want you to do, on the source code, you are in Pico. Okay, let me take a screenshot of that. So here in Windows, I can use, for example, snipping tool. It is there. Click on new. I'm going to say I need a screenshot of that. Let me put it like that. Okay, I have the screenshot. Edit copy, and you come in the Word document, and you do edit paste. You give me that. I will not be happy. Why? Because I need to type that. If I want to verify your code, I need to type that. So the code, please be sure that you do something like that, no? You remember changing the font so it's proportional. Okay? And now, if you want to show me a listing of the actual directory, I am, for example, let me go out. I'm here in the desktop and you want to show me a listing with all the information of the file. That's a lot. So let's do with the bash file, the .bash file. That's perfectly okay that you use snipping tool where it is. It is here. Let me do a new screenshot. Did I already press new? Okay. You want to show me this? So you make a screenshot of that. Edit copy. And you paste it here. That will be fine. Because you are showing me that what you are doing is working. Or you are showing me a command. So here I just need the result, but I'm not going to, if I have to type something, I just have to type ls space -l space star.bash. So that's fine that here you give me a screenshot, but don't give me a screenshot of your code. Give me the actual code, okay, like here. So I can edit copy it, edit paste it if I need to do it, no? Okay, what else can I tell you? Present, don't forget if you write an if, for example, let's do a program that shows the minimum value, that asks for 2 integers and show the minimum value. So I define v1, v2, and min. And I ask the person to give me the first value. Print enter the first value. That. Okay, with scan F, I'm going to read. I'm saying it's a decimal value. To change the double quote in curly double quote. So I correct it, as you can see. No, I need to make a copy of these two lines. Let me make a copy. So enter the second value. I'm going to read V2. Then I have if. So V1 is greater or equal than V2. The minimum will be V1. Otherwise, the minimum will be V2. And you print the result. The minimum value is the minimum value is %d, and you want to show me. Okay, and return 0 here. This is the error status that we get in Bash. Okay, let's say that you have done this program. Let's save it as a PDF file. Save it as here in the desktop. Is it still open? Yeah, it's still open. Let me close it first. Save as a PDF file. PDF, replace, yes. Okay. So look at the indentation. I see exactly there is an indentation. It's easy to read. But if you don't put indentation, you make it very difficult for the people to understand what you are doing. And if you put, for example, here there is no comment. You should put some comment in your source code, no? But the important thing is I can do that. Okay, because we are in a teaching institution, we want people to learn. So let's call it min.c. I'm just going to paste it here. Didn't come with the space. Let me try to DOS to Unix. Let me install DOS to Unix. Get install DOS to Unix, which should solve the problem. Okay, let's see if that is enough. So DOS to Unix. Let me edit the file again. Didn't. I will have to do some work, unfortunately. Let's see. Maybe if I bring in Pico do it better for me. Edit, paste. No, I did the same thing. Okay. But at least there is a way for the person that is going to use your code to get it from your report. If you don't allow the person to get, because you do a screenshot to get the code from your report, sometimes the way to verify if there is a problem is like that. No, we want to run your code. So make it easy for the people to grade what you have done. Okay. There is a return 0 here. Here we are done. Okay. So let me save it. I will compile it, call it min. Okay, it's not print, it's printf. here and here. Print format, no? Print format. Let's do it again. Value 45, 67. Oh, the minimum value is 67. So I have a bug in what I wrote. Okay, very good that I'm computing the minimum value. You cannot give me a code that you don't try. You need to try the code and be sure it's work. Okay, we have report where the code is not working. You see, I did try my code to be sure it's work, no? So you need to do the same thing. And if it doesn't work, tell in your report it doesn't work. Don't put code without saying if it works or it doesn't work. And if it works, do a screenshot to prove that it works, no? For example, now that I've debugged my code, let me change it here. Control S, yes. Let me compile it. So I'm going to do an execution and show that my code works. So 12, 45, the minimum is 40, it's 12. Let me put, for example, here 33 and 7, the minimum is 7. So either if the minimum is the first one or the last one, I have good results. So now I take my screenshot, new screenshot. I want a screenshot that includes from here, let's say to here. Okay, my screenshot, edit copy, and I put it in my report. Here is the proof that it works. Okay, and of course, you write things before, no? So here is the proof that I compile it and it works, no? Blah, blah, blah. Okay, you need some text in what you write, but you need to do high quality report. Okay, so look the exercise that we are going to do today. Done in Word. You see the quality? So I make an effort to have a nice presentation for you. Look, just what I show you recently. I make a table, put some gray, put the code. Look at it, it is in consolas, so it's proportional. Okay, so in the next report, I need an effort from you. And I need a much quality report. So let me tell you, Syed is with us today. Is our GTA in the course. He will be grading your homework number 1. He already did it, so he will send it you the result today. Okay, and I need you to start working on your second report on symmetric cryptography. Of course, remember all I told you. When you present code, don't give me a screenshot of the code. Put the code inside a Word document, but put it so that it's proportional. It doesn't use, for example, the default font like Calibri or Arial, which are not proportional. Okay, so look at the difference between proportional and non-proportional fonts. This is a M. Put some 1. Let me put them with a proportional font. Proportional font is that all the characters have the same width. So look at, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 M and 10 1. Let's put, for example, 10 L. Let's put also 10 stars. Exactly the same space. Now, if I change that to Arial, which is a font that is very common in, look at 10.1. the space that they represent. And look at 10M. You don't want that when you present code. So when you present code, be sure you change the font and you don't have this problem, okay? Okay, do you have any question on that? Okay, exercise number 1. Compute the following modular inverse. If possible, you can use the Euclidean algorithm. Okay, so I want to compute the inverse of 80 modulus 171, the modular inverse. So how do we do that? First of all, we need to know if it does exist. Sometimes it exists, sometimes it does not exist. So I want the inverse of 80. So I want to solve the equation 18 times x is congruent to 1 modulus 171. So before we start, we need to see if it exists. What is the condition for finding an inverse? That 80 and 171 have to be coprime. So the maximum common divisor have to be 1. So let's see if it's true. So 80 is what? 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So 80 is 2 to the power of 4 times 5. What is 171? 3 times something. Okay, I don't know what is the something. So I'm going to bring the calculator. Where is my mouse now? So 171 divided by 3 is 57. On 57, I can divide it furthermore by 3. It will give me 19. So this is 3 times 3 times 19. And that's it, no? They are already, it's prime factors, no? It's 3 times 3 times 19. So it's 3 squared times 19. So the maximum common divisor, the greater common divisor is 1. So when you need to factorize, only when you have very big number, you can use, for example, a command that is called factors. There is a command in the operating system that is called factors. So give me the prime factor of 80, for example. So look at 22225, which is 2 to the 4 times 5 to the 1. Let's do the same thing with 171. So give me the factor of 171, the prime factor. So 3319, this is exactly what we found, okay? So of course, for very small number like that, we can do it by ourselves. Like big number, we ask the computer to do it for us. Okay, so the greatest common divisor is 1. So there is we do have solution to this equation. So there is a method to find the smaller positive modular inverse. So we are going to express 171 in function of 80. So 171 is 80 times 2, which will be 160, plus 11, isn't it? Okay, please, if I make a mistake, let me know. Okay, so this is in function of 80. Now we are going to express, 80 in function of 11. So 80 is 11 times 7 plus 3. 11 times 7 will be 77 plus 3 is going to give me 80, no? Now let's express 11 on function of 3. So 11 is 3 times 3 plus 2. 3 times 3 is 2. 3 times 2 is 9. 9 plus 2 is 11, sorry. Now let's express 3 in function of 2. So 3 is 2 times 1 plus 1. Since I got a 1, I stop here and I go back. So let's extract 1 from here. We can say that 1 is 3 minus 2. So we already took advantage of this equation, of this line. Now let's take advantage of this line. We are going to replace the 2 that is here with this 2. So we will have 3 minus 11 minus 3 times 3, isn't it? I just took the 2 here. 2 is 11 minus 3 times 3. So this will give me 3 minus 11 plus 3 times 3. So I put the 3 together. This will give me 3 times 4 minus 11. Okay, now we are going to take advantage of this one. So with this one, I can say that 3 is 80 minus 11 times 7. So this 3, I'm going to replace it by 80 minus 11 times 7, because this is what we found, times 4 minus 11. See if I can scroll down. Okay. So this will be 80 times 4 minus 11 times 7 times 4, 28, no? Minus 11. So I put the 80 together and the 11 together. 80 times 4 minus 11 times 29. Okay, just in case, I'm going to check that I've not created a problem here. Let me use my calculator here and verify that everything is okay. So 80 times 4 minus 11 times 29 to see that it should be 1. Okay, good. So no mistake up to now. Now I'm going to take advantage of the last line, the first line that we wrote, this one, and replace the 11. So 11 is 171 minus 80 times 2. So this 11, let me replace it. So minus 171 minus 80 times 2. Minus 80 times 2. 80 times 2 times 29. So let's put the 80 together and the 171 together. So this will be minus 171 times 29 plus 80 times 2 times 29 is 58. So if I put the 80 together, here we have 80 times 4 and 80 times 58. It will be 80 times 62 minus 171 times 29. Before I proceed, let me verify that I didn't make any mistake, because I don't want to repeat the thing. So minus 171 times 29. Okay, it's 1. So just perfect. We arrived to it. So we know that 1 is equal to that. So let me now write this modulus 171. So let me put this first. 80 times 62 minus 171 times 29 is going to be, because this is 1, is going to be 1 modulus 171. So when you do modulus 171, let me verify that it was what, yeah, we are modulus 171. You can remove any factor that is 171 times something. So I can remove this one, or I can add. So I'm going to remove this one. So let's say that this one, I'm going to remove it. So it's the same as 80 times 62 is congruent to 1 mod 171. Now, as I can remove, I can add. So I'm going to add one that will make my life easy, which is 80 times 171. Oh no, I don't even, no. It's already there. I already have the inverse. I don't need this last time. So the inverse of 80, I was looking for the inverse of 80. Modulus 171 is 62, and that's it. So let's verify that. Let's verify that if I multiply 80 by 62 and compute the modulus 171, I have 1. Perfect. So I find the inverse. Okay? So we answered the question. It was find the inverse of 80 modulus 171. Okay. What about find the inverse of 87 modulus 171? So let me start with a new file here. So this time we want the inverse of 87. So we want the inverse of 87 modulus 171. So what is 87? It's divisible by 3. And 171 is also divisible by 3. So it's 3 times, let's do it. So 87 divided by 3, 3 times 29. And 29 is already a prime number. So 3 times 29. Okay. On 171, if I remember correctly, it was this time 19, no? Isn't it? Let's verify. 9 times 19 was 171. So what will be the greater common divisor of 87 and 171? It will be 3. There is no solution. So we are not going to start. There is no solution. There is no inverse of 87 modulus 171. So I just stop there. I say there is no solution. I just show that they do have a greater common divisor that is not 1. Okay, let's do exercise 2. Verify the following modulus 5 multiplication table. Okay, let's verify some of them. So let me put the table here. Do you understand this table? You understand that we are working modulus 5. So for example, let me do 3 times 2. So 3 times 2 is what? Is 6. But if I'm working modulo 5, it will be what? It will be also what? If you take 6, you divide it by 5. What will be the remainder? Of course, it's 1. Remember that I can add to 6 any multiple of 5 or subtract any multiple of 5. So I can do 6 minus 5, and 6 minus 5 is 1. So 3 and 2 should have a 1. And of course, if the multiplication is commutative, 2 and 3 should have a 1. Good. Let's do, for example, 3 times 4. 3 times 4 is what? It's 12. If I am modulo 5, of course, I can write, for example, 12 minus 5 is 7. I can say 7. But better, directly 2. The result is 2 modulus 5. So let's see. 3 and 4, we have a 2. And 4 and 3, we have a 2. Let's write 4 times 4. 4 times 4 will be what? Will be 16. If we are modulo 5, it will be 1. Okay? So intersection of 4 and 4, we have a 1. Perfect. Okay. According to this table, what is the modular inverse of 1? How do I find that? So for example, I take row 1 and search for a 1. It is there. So the modular inverse of 1 is 1. What is the modular inverse of 2? I take row 2, I search for a 1. It is there. So the modulus inverse of 2 is 3. 2 times 3 is 6. Modulo 5 is 1. What is the modular inverse of 3? I take row 3, it says 2, of course. Is the symmetric. And what is the modular inverse of 4? It's 4. 4 times 4 is 16. And 16 is 1 modulus 5. So write the same table for modulus 10. Okay, it's going to take us some time to do it. Let's program it. So I want you to do a program that I will say table 5, and it show me the previous table. Or table 10, it show me the table that we need. So let's do a program like that. Let me create a file that we are going to call table.py. I'm going to give me write to execute it. So user plus execution mode. Okay, I'm going to edit this file. So let me put the hash bang. There is a directory that is called user bin python 3. We are going to use. Okay. So what will be the first thing that I need to do to generate this table? For example, to generate this table. I want to generate as it is there. So I need to read arguments. So I'm going to import sys, isn't it? So the first thing, I'm going to check that the person put a total of 2 arguments, the name of the command and another argument specifying the table that the person wants. So if the length of what? sys.argv is not 2, I have to guide the person. I say, you are not using the command as you should use it. So print, the usage is the following. So usage on this line, the file where I want to send that is the standard error. Okay, then I will tell the person, you put the name of the command and you put an integer for the table. Okay, and the name of the command will be where? In sys.argv sub 0. Yeah, I think we are good. Then, if the person do have this problem, let me tell the person that there were a problem and the exit status will be 1. So let me verify that this at least works. I go slowly by slowly. So let me go to the desktop and run my program, which is called table. Without anything, I say, oh, you forgot the integer. So don't forget the integer. So let's say that I'm very confused and I put more than 1 integer. Say, no, it's just 1 integer. Okay. Table of 5. If I look at my exit status, it's 0. If I put table without anything, my exit status is 1. Okay, because we did say, if the person go here, I want an exit status of 1. Otherwise, I want an exit status of 0. Exit status of 0 is when it's successful. Okay, let's say the person typed something with just 1 integer. So let's save this integer in n. So I need to convert it. It's a string. So there is an operator that is called int that will allow me to convert it. So it is in sys argv sub1. Okay, I have my integer. What is the first thing that I need to do? Okay, I'm going to put 2 spaces for the first integer, then a pipe to separate, then maybe 1 space, another integer, a space, another integer. I'm going to do it like that. You understand? This is the format. So let's do the first line. This first line that will show her the header of the table. So for I in range of n, what should we do? Before we do that, we need to put space, 3 space. So let me do it. Print 1, 2, 3 space, a pipe on a space. Okay, on a space. So I want this, and I want to stay in the same line. So now what should I do? I show an integer of 2 characters and put a space. Okay? So I'm going to say print an integer which will be I, but I want it over 2 characters. So I can do, for example, %2d. And I want a space after, we say? Yeah, we want a space after. Or we want it before. Yeah, we want it before. Because before, okay, like that. So %e and end. Okay, I think this should be okay. Let me comment that. So a comment in Python will be like that. Let's see if it shows me the first line correctly. So I need another shell and run it. I want a table of 4. Okay, so it looks like that it do it well. And of course, when I finish, I need to go to the next line. So let's execute it again to see. I want a table of 4, so it starts well. I think here there is 1 more space. So the space, yeah, there is 1 more space. So I need to remove a space. Yeah, I put a space here, it's not necessary. Okay, so then what should we do? We are going to do the line of 0, then the line of 1, the line of 2. So we need 2 for loop. Nested for loop, no? For I will be the row in range n, and we will have a for j in range of n. What should we do? So before we go there, we need to write. So here we have how many spaces? 1, 2, 3. So we need to write 1 space, an integer of 2 characters. And this integer will be I. And I want to stay in the same line. Okay, and here what should we do? We are going to write, oh, by the way, there is something missing here. I need that, okay? The pipe. Okay. So then we are going to do space integer, space integer. So let's print the result. So space integer of 2 characters. This integer will be what? This integer will be what? So it will be I times j modulus n. So modulus n. Is it okay? Maybe. Let's try to run that to see. I want a table of 4. So here we have a problem. Let's check. Print. Yes. Let me just put parentheses here, just in case it gets confused. Oh yeah, it gets confused because we have %%. That's true. Okay, so here 1, 2, want a space. Here we say 1 space. So yeah, we are going to remove 1 space here. We just want the integer. Okay, let's see if it's worked. Oh, by the way, there is something that I forgot. Let's put this horizontal line. So let's add this horizontal line in our program. Once we do that, we need an horizontal line. So one horizontal line, it will be print the character, this one, a certain number of times. So how many times? It will be I times 2 plus 1 no, it will be I times 3 plus maybe not 1, I don't remember, maybe plus 4 plus 5. Let's see. Table 4. So because here we have 1 more. So there is a constant. Plus 3, 4, yeah, at least it will be, let me think about it. For each of these integer, we will have 3. 1, 2, 3. Yeah, and here, 1, 2, 3. Yeah, and here we have 1, 2, 3 plus 1. So it will be plus 4. Let's do it again. So there is 1 missing. Oh yeah, because if we have 3, we need to do it 4 times. So it will be I plus 1. I plus 1 times 3 plus 4. I think it's correct now. Okay, let's see. Let's verify my table. 0, 0, 0, 0, 0, correct. 0, 1, 2, 3, 0, 1, 2, 3, 0, 2, 0, 2, 0, 2, 4, 1, 3. So there is a problem here. Oh, 0, 1, 2, 3. By the way, I have, did you say table of 3? That was table of 5. Yeah, I did table of 4. Let's do table of 5. Sorry, it was not the same table. Let's verify table of 5. Oh, 0, 2, 4, 1, 3. It does work. For the 2, the 3 have 0, 3, 1, 4, 2. And the 4 are 0, 4, 3, 2, 1. Okay. So I think I'm good. Let's do table of 10. And let's verify some of them. Let me put it here. Okay, for example, let's verify this one. So 4 times 7, 28. 28 modulus 10 is 8. Correct. Let's verify, for example, this one. So 8 times 3, or 3 times 8. Doesn't matter if you read here and then here, or here then here. So 3 times 8 is 24. 24 modulus 10 is 4. Okay, it does work. Okay, so if I ask you, what is the inverse of 7 modulus 10? It's 3. Okay, 3 times 7 is 21. Modulus 10, it will be 1. If I ask you what is the inverse of 8 modulus 10, it doesn't have an inverse. As you can see, there is no 1 here. Why? Because 8 and 10 have a greater common divisor that is not 1. So it's why it doesn't have an inverse. What is the inverse of 9 modulus 10? It's 9. 9 times 9 is 81. Modulus 10 is just 1. So the inverse of 9 is 9. Okay? So you see this small program that I just did? If you have to present it well in your report. So you see, when I need indentation, I put indentation. I make it clear for everybody. So I need you to do the same thing in your report. Okay. Exercise 4. Resolve the following equation. To do so, you can use one of the property of the modulo operation. Okay, which is this one. If A is congruent to B modulus n, and C is congruent to D modulus n, then A plus B will be congruent to B plus D modulus n. Okay, we want to resolve this one. Let's see. This one is quite easy to resolve because we already have done a lot of exercise like this one. So it will be just a review for us to resolve this equation. So let me get a new place to work. We want to resolve 32x is congruent to 1 modulus 1409. Okay, so what are we looking for here? What is x? X is the inverse of 32 modulus 1409. This is the definition of the inverse. So we are looking for the inverse of x. We are looking for the inverse of 32, sorry. Modulus 1409. So before we start any computation, we need to check if there is an inverse. For that, I need to see that the greatest common divisor between 32 and 1409 is 1. So let's write 32 as multiplication of prime factor. This is 2 times 16, which is 16 is 2 times 8, 8 is 2 times 4, 4 is 2 times 2. So this is 2 to the power 5, only 2. In this one, do we have 2? We don't have 2. Because if something is a multiple of 2, it's end with 0, or 2, or 4, or 6, or 8. This doesn't end, so it doesn't have 2. So I can just stop there. I can say that the greater common divisor is 1. So we do have an inverse of 32, modulus 1409. So for that, we will use the same method. We want to express 1409 with 32. So it's 32 times something. Okay, I don't know what is this time. So I'm going to use my, let's try to put them so we can work with both. My Python calculator, and I'm going to say divide 1409 by 32. So it's 44. And I also need the modulus. Oh, very easy. We already got a 1. So it's time 44 plus 1. So we don't have to go further away because we already have the 1. So we can say, oh, bingo. So 1 is 1409 minus 32 times 44. Now, let's do that modulus 1409. So I will have, let me write this first. So 1409 minus 32 times 44 will be congruent to 1 modulus 1409. So I can make this one disappear. Any multiple of 1409, I can make them disappear, or I can make multiple of 1409 appear. So I'm going to make this one disappear, and I'm going to make another one appear. So the one that I'm going to make appear is 32 times 1409 minus 32 times 44. It's going to be 1 modulus 1409. So let's factorize 32. 32, 1409 minus 44 will be congruent to 1 modulus 1409. So this will be 32 times what? Okay. So 1409 minus 44 is 1365. Let's verify that to be sure we didn't make any mistake up to now. So I'm going to take my calculator and verify that. So 32 times 1365 modulus 1409. 1, perfect. So I was looking for the inverse of 32 modulus 1409. This is the inverse. So what we can say, that x, I was looking for x, will be what? Will be congruent to 1369 modulus 1409. So this is my solution of the equation. Let me show you the initial equation again. The initial equation is this one. 32x must be congruent to 1 modulus 1409. Okay, so what are the possible value of x? Let's write down some. We have an infinity number of solutions, no? So let me write some. For example, let me bring my calculator. I'm going to do 1365 minus, for example, 2 times 1409. This is one of the solutions. So it's 1453. Let me put another solution. Here, another solution will be negative 44. It's another solution. Another solution will be, of course, 1365. 1365 plus 1409 will be, because it's modulus, so all of them, let me do plus 1 time, 2774, and blah, 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 blah. 2774. Okay, so remember, this is the original equation. So let's verify that this is a solution. with Python. So let me put it here. Okay, we have some space here. So x equal negative 1453. So let's do 32 times x. This modulus 1409. It should be 1. Good. Now let's try another x. If x is equal to negative 44. Should be 1. Good. Let's try another value of x. If x is equal to 1365. Good. Let's try another x. 2774. Okay? So those are solutions. Now, if I tell you, okay, do a program that show me that those are solutions. We have an infinite number of solutions. No, let's write a small program that show us that. So solution, let's call it solutions. Solution.py, the hash bang, user, bin, Python, tree. So what do I want to show? Let's start. Let's do the solution between for x in range. We are not going to do all of them. We can do all of them, but I'm going to do the solution that are between 7,000, negative 7,000 and positive 7,000, both inclusive. So if I want both inclusive, it will be like that. So what should I write here? If it's solution of the equation, show me it. Otherwise, go to the next one. So I will say if I'm x modulus 1409 is 1, if it is 1, show me the value of x. So print a solution. Let's just put solution on the solution that we just find, like a decimal number, and we have it in x. So this program should show me all the solution between negative 7,000 and 7,000. So let me make it executable for me. Solution. Okay, so let's see. We have 1453. We did find it. We have negative 44. We did find it. We have 1365. We did find it. We have 2774. Okay, we could have keep going because it's all of them plus. If I want to, how do I go from this one to this one? We just add 1409. It's modulus 1409. So all of them are there. Okay, so we did find the solution. So as you can see, look at the power of that. I just do small program to verify that I didn't make any mistake. Okay, let's solve another one. Oh, this one is much better. Let me create a new area to work. And we want to resolve 5 times x is congruent to 9 modulus 30. So of course I can write a Python program for that. So tell me, what is your idea? What can we do? So we want a product congruent to 1. So we just have to find the inverse, because we know how to find the inverse. It's very easy. So what transformation can I make here to have at the end a first term times a second term is congruent to 1 modulus 13. This is what I want. I don't want this 9. I want a 1. So what can I do? Because I know how to compute the inverse. So 9 is 8 plus 1, isn't it? So I can say, oh, okay. Just rewrite that like 8 times x is congruent to 8 plus 1 modulus 13. What about if we pass this 8 on the other side? We get 8 times x minus 8 is congruent to 1 modulus 13. So 8 times x minus 1 is congruent to 1 modulus 13. Bingo, we have a term times another term is congruent to 1 modulus 13. This is what we want. So we want to find what is the inverse of 8 modulus 13. Oh, what about our small program that we just did? Let's show the table of 8. So it's called table. No, the table of 13, sorry. The table of 13. Ah, yeah, it is done for 2-digit. Here it's a little more difficult to see. But in the line of 8, I see 5. So I should find 5 when I solve that. 5 modulus 13. Okay, let's do it. So first, before I start, I need to show that 8 and 13 are coprime. So 13 is a prime number. And 8 is 2 to the power of 3. So the maximum common divisor is 1. So they are coprime. So I can start. We need to express 13 in function of 8. So 13 is 8 times 1, isn't it? Plus 5. So now we need to express 8 in function of 5. So 8 is 5 times 1 plus 3. Now we need to express 5 in function of 3. 3 times 1 plus 2. Now we need to express 3 in function of 2. 2 times 1 plus 1. And we stop here because we got the 1. So we can go back. So let's take advantage of this first line. So with this first line, we can say that 1 is 3 minus 2. Now let's replace, using this line, let's replace this 2 with the 2 that is there. So 1 will be 3 minus 5 minus 3. Okay, this 2 say that 2 is 5 minus 3. This is true. So this will give me 3 minus 5 plus 3, which is 3 times 2 minus 5. Now let's replace this 3 here. I don't like the equal here. I like it in front of it. So let me put it in front of it. Okay, let's replace the 3. So 3 is 8 minus 5. So 8 minus 5 times 2 minus 5. And let's express things in function of 8 and 5. So this is 8 times 2 minus 5 times 2 minus 5. It's giving me 8 times 2 minus 5 times 3. 8 times 2 is 16. 16 minus 15 is 1. So we go well. So now I'm going to take the next one, which is this one. So 5 is 13 minus 8. So I'm going to replace 5 by 13 minus 8 times 3. So let's give me 8 times 2 minus 13 times 3 plus 8 times 3. So we are going to group the 8 together. 8 times 2 and 8 times 3 is 8 times 5, which is 40. Minus 13 times 3 is 39. 40 minus 39 is 1. That's true. So now we can put the modulus. So this is 1, no? So if I write 8 times 5 minus 13 times 3 is equal to 1, modulus, we are doing it 13, no? Modulus 13, let me just verify in the upper part that we are modulus 13. Yeah, we are modulus 13. Okay, so I can make any something times 13 disappear, and I can make it appear. So I'm going to make 8 times 5, and I want to appear this one. So I can make a multiple of 13 disappear and another multiple of 13 appear. So if I put the 8 together, 13 plus 5 will be 18. Yeah, 8 times 5. Yeah, this is 18, which is 5. Times 5. Oh, I went too far away. Like last time, I don't need that. I don't need that. I was looking for the inverse of 8. The inverse of 8 is 5. This is what, if I remember, when we run Python, it's what it told us. Yeah, the inverse of 8 is 5. So now that I know the reverse of 8 is 5, what can we say? That this equation, what are the solutions of this equation? 8 times x is congruent to 9 modulus 13. So x will be what? Will be 5 modulus 13. So the solution are which form? The solution of which form? So they can be very negative, but I just want to show some of them. So let me show, for example, I'm going to show, let me run Python. I'm going to show 5 minus 3 times 13. So negative 34 is one solution. You do another one. Minus 2 times 13. Negative 21 will be another solution. Negative 21, negative 8, negative 21, negative 8. Negative 8 plus 13 will give me 5. 5 plus 13 will give me 18. 18 plus 13 will give me 31. So all those are solutions. So I can verify it in Python. So let's put x equal negative 35, for example, negative 34. And let's verify that 8 times 9, 8 times x, sorry, modulus 13 should be 9. 8 times x modulus 13, yeah. And 9 is 1. Oh, should be, no. 8 times x. let me see what we did right. I did a mistake at one point, so we will have to, let's see. Oh, this is, look at, yeah, I saw where is the mistake. What we have to resolve is that. So we have x minus 1, not x. X minus 1 have to be, so it's x minus 1. Here it's not correct. It's x minus 1 that have to be congruent to 5 modulus 13. So it will give us what? That x is congruent to 6 modulus 13. So the solution of x will be, okay, let's just put some 6 minus 13 will give us minus 7, no? Minus 7 plus 13 will give us 6. 6 plus 13 will give us 18. 18 plus 13, 31, isn't it? So let's verify that. So x can be negative 7. Bingo, 9. X can be 6. Bingo, 9. X can be 18. Six plus 13, 19. Or 19. X can be 19. Bingo, no? So here, you see, we do small error and nobody say anything. So 19 here. 19 plus 13 will be what? 32, no? So 19 is a solution, 32 is a solution. Let's see. 32 is a solution. Okay. Of course, we can take our program, our previous program, and modify it a little. So let's take our previous program and modify it. Okay, I want too big. I'm going to say between negative 15 and 15 inclusive. So I want 8 times x modulus 13 to be congruent to 9. Okay? 8 times x modulus 13 to be congruent to 9. So let's run that. So we see the negative 7 that we did compute, the 6, the 19, the 32. Okay, we didn't compute, we don't put any others. Is it okay? What about this one? This one is easy. You need to compute the multiplicative inverse of 25 modulus 42. So no challenge. What about this one? What will you do with this one? Let's see. If I have 18x is congruent to 11 modulus 19. What can I do? I want something a times b congruent to 1 modulus 19. So
could you do 18 times x minus 11 parentheses?
Maybe, but let's start with something very easy. What about if we add 9 on both sides? So I can do 18x plus 9 is going to be congruent to 11 plus 9, modulus 19, isn't it? I add 9 on the left side, I have to add 9 on the right side. So this will be what? Here, 11 plus 9 is 20. And this will be 9 times 2x plus 1, isn't it? How can I replace 20 if I am modulus 19? Remember, if you are modulus 19, you can add 19, you can subtract 19, you can add any multiple of 19 or subtract any multiple of 19. So I can do 20 minus 19. It will be 1. Bingo, we have A times B. So we need to compute the modular inverse of 19, the modulus inverse of 9, modulus 19. And it does exist, okay, because 19 is a prime number, and 9 is 3 times 3. So the GCD is 1. So it does exist. When I find it, I resolve this equation. So let's do it fast here. Let me bring my Python calculator. I want the inverse of 9. So modulus 19. So 9, where is the 1 here? Where is the 1? It should have a 1. In line here, it is there. So it's 17. Let's verify that 9 times 17 is congruent to 1 modulus 19. Let's verify that, which means that the inverse of 9 is 17, modulus 19, or the inverse of 17 is 9. So let's just verify that here to be sure. Python 3, so 9 times 17 modulus 19, it's 1. Okay, so they are inverse to each other. Okay, so what can I say? 2x plus 1 will have to be congruent to 17 modulus 19. This is the solution. So 2x will have to be, if I pass the 1 on the other side, 17 minus 1 will be 16 modulus 19. Yes. Could have done something better. Maybe there's something better to do, but there is a property when we arrive to this that say that this is exactly, I can divide by 2 here and 2 here. So there is a way to show that this is exactly the same as that. So the solution will be 8. 8 plus 19 will be what? 27. 27 plus 19 will be what? 46, no? So the solution will be that. Let's program it to see if we find the correct one. So we have, of course, negative solution, no? So for example, the negative solution will be 8 minus 19, which is negative 11. So all of them are solution. Let's see. What is the program that we did? It's called solution, and I want to resolve Let's see what I want to resolve. I want to resolve 18 times x is 11 modulus 19. So let's see what we find when we run our program. Solutions. Okay, so for example, it did find some, let's see. We did find negative 11, negative 11, 8, 27, 46. Okay. Okay, there were something that I just go over it, which is I divided it by 2 and divided by 2. There is a property that allows me to do that. We didn't see it, but there is one that allows me to do that. Okay, it's why I did it. Okay, so I think it's time. Yeah, so please go over homework number 2 and do a good report, please. Okay? Okay, I see you next week.